Okay, exercise 1003 is about vector projection. I kind of like to call that shadows at noon. So what I mean by that, we've got the vector u here, and we're projecting the vector v onto u. So imagine you as the ground, you've got the sun up here, it's noon, so the sun is high in the sky, really tall, and the shadow of this vector v is the projection. Okay, the blue vector here, it's the projection of v onto u. That's how you read that. Projection of v onto u. The one that you're going onto is the subscript 1. So if u is the ground, then the shadow of v onto u at noon, when the sun is directly overhead, is called the projection of v onto u. Now, this is the formula. I'm going to prove that formula. It is not on the reference sheet. It is a little bit tricky to memorize, but you must memorize it. The key here is the one you're going onto is there, like it's mentioned 3 out of 4 times here. This one here is only mentioned once. We're projecting onto this vector. So yeah, you really just have to memorize it. Just a second diagram here. If that vector v, if this angle is more than 90 degrees, then the projection is going to go in that opposite direction. And just also a note that this vertical line here that makes a right angle with u, or negative u in this case, that's the component of v perpendicular to u. So v is made of components. It's got this component, it's got that component. And if you get a question talking about the component of v perpendicular to u, you're finding that line there, or that vector. You can do that by subtracting, of course. So that vector is v minus the projection. So just a bit of vector subtraction, or you can do a bit of SOHCAHTOA if you're trying to find the length of it. Now I'm just going to prove that formula. So we know that the dot product is given by this formula. That's the first thing we're going to think about here. And if I just rearrange that, then cos theta is equal to the dot product of u and v divided by the product of their magnitudes. We also know, just looking at this diagram here, simple SOHCAHTOA, that cos theta is the adjacent over the hypotenuse, so it's the projection over v. And that's magnitude of each. So the magnitude of the projection over the magnitude of v is equal to cos theta just by SOHCAHTOA. Now, all we have to do is make those things equal to each other because they're both equal to cos theta. So if I make this one equal to that one, the magnitude of v onto u, the projection of v onto u over the magnitude of v equals the dot product of u and v over the product of their magnitudes. Now I just need to multiply each side by the magnitude of v. So they're just going to cancel nicely. So the magnitude of the projection is equal to the dot product of u and v over the magnitude of u. So that's quite important. So that's the magnitude only. You've got to be a little bit careful there with this proof. And so we just need to multiply that, though, that magnitude, by the unit vector in that direction. That's all we need to do. And that'll give us that as a vector. If we've got a unit vector and we say this projection was 3, we multiplied that vector by 3, then we would get that projection vector. So let's do that. So the projection is the magnitude, as I said, multiplied by the unit vector. So the length of it multiplied by the unit vector in that direction. The unit vector in that direction is this, the vector divided by its magnitude. And this first part is just coming directly from what we saw up there. And then we just put that all together, and that's our formula. So that's the proof of that formula. Okay, feel free to watch that again or pause it or rewind it if you need to. So let's look at this example. We've got the vector A equals 3, 2, the vector B equals negative 1, 4, and we want to find the projection of A onto B. So it's B that's the subscript, and it's b that's going to be used in the formula because we're projecting onto b. So we do their dot products. We divide that by the magnitude of b squared, the one we're projecting onto, and we multiply that by b. Okay, so one of these magnitudes here works with the b to be the unit vector up here. So we can see here we put those together to make them squared, and that's already there. So let's put some numbers into that. So the dot product of a and b, of course, is 3 times minus 1 plus 2 times 4. And then I need to divide that by the magnitude of b squared, so negative 1 squared plus 4 squared. And I need to multiply that by b. So putting that whole fraction into my calculator, I do get 5 on 17. Now, it is okay to leave it there if it's not going to simplify nicely, which obviously this one is not going to. So we can just stop if we want to, but I will just write again what it will be if we did go a little bit further. So negative 5 on 17 for at the top. And, oh, I've got a mistake there. That should actually be 20 on 17 at the bottom. So negative 5 on 17, 20 on 17. I didn't multiply the 5 and the 4 there.